political ramblings were mercifully left unrecorded. Okay.
Yep. All right, we're recording now.
Okay, great. Okay, good morning, everyone. Today is a workshop on C++ for C programmers. So this is a workshop not C++ from the ground up, but C++ for people who are moderately well versed in C programming, who would like to make the step up to C++. This is a workshop organized by TAC and issued under XSEED, and as such we follow the XSEED Code of Conduct. If something bothers you, contact me, Jason, who is the event organizer, or one of the XSEED Ombuds people. Where do you find these slides? I've now twice posted in Slack a link. So this is the download link for all my for the course materials. So this workshop is based on a semester course that I and other people from TAC teach, which is a C++ from the ground up. And so I've written a textbook for that, which is C++ from the ground up, and then extending into obscure stuff that I thought is interesting to know. So I've posted the link in the chat. That is that link. You can also go to this link. I've written by now over the past dozen years 3 textbooks, one for scientific computing, one for parallel computing, parallel programming, and one for C++. And on this book you can find everything, including the source repos. It is nice and quiet over here, so if you have any questions, speak up. You have to unmute yourself. Please keep yourself muted while you're listening, but in Zoom, if you hit the space bar, you unmute yourself, and I welcome interruptions. I will try to take a break often enough that you can interpolate my stream of consciousness. Okay. So yeah, today's workshop is not using any TAC machinery. I am logged into a TAC machine here. For demo purposes. But I'm assuming that everyone has a C++ compiler on their local machine. So either you have GNU, in which case it's G++, you have Clang, then it's Clang++, you have the Intel compiler. I'm sure that the Portland group has a C++ compiler too. So I hope you have a C++ compiler, because we're going to be doing a couple of lab exercises. I want you to have seen just some of the basics, and I think you internalize things much better if you actually think about it. Okay, we're rolling by now. So C++, why C++? Stop coding C. So unless you're dealing with legacy code bases, I would argue that for almost all purposes, you really want to use C++ instead of C if you're developing new code. C++ is a more structured and safer variant of C. There are very few reasons not to switch to C++. Okay, now here's the pitfall. C++ basically contains C as a subset. I mean, if you go into obscure things like undefined behavior and late extensions to C99, then C is not a subset of C++, but for most practical purposes, C is a subset of C++. So you can say, I can program C, therefore I can program C++. Yes, no. There are a number of things that you're used to doing in C, like arrays and string handling, that really have been replaced by better mechanisms in C++, and you should stop using the old style C style idioms. There is an exceedingly entertaining and insightful lecture online by Kate Gregory. She is worth watching for all of her presentations, but start with this one. I came to the same conclusion as what she's arguing here, is that there are too many lectures and courses online that teach C and then have C++ as the cherry on top. That is the wrong way of going about it. You should not learn the whole of C and then learn what C++ has extra. You should really not, you should completely abandon some of the C mechanisms and use C++ instead. Watch that lecture after I'm done here, so tonight at home. Okay. So what every C programmer knows about C++ is object-oriented programming. So that will be the first part of this workshop. So most of the time before noon or before the lunch break, I will spend on object-oriented programming and a little bit on some simpler stuff, and then in the afternoon we'll go into non-obvious things in C++. So I'm assuming you know C, so you know how to code a loop, you know how to write a function, you know what a struct is, and you know what a pointer is. Okay, pointers are sort of optional, but we'll go into new style pointers. Okay, does everyone have these lectures in front of them? Well, does everyone know where to find them? Speak up if you're catching up. We are now at 22 participants. Okay, someone said no in that case. Here is the link again. Download the last 2 PDF files. About this course, all right, here's the link. Slides and codes are from my open source textbook. All 3 of my textbooks are completely open source. Okay, C++, just to get some of the boring stuff out of the way, has evolved quite a bit. There is C++ 98, which is the default setting of your compiler. And then there is C++ 2003, which is basically the same. And then a number of years, nothing happened. But C++ 11 was a major revision of the language. And so modern C++ is really 11 and up. And in this book, in this workshop and my book, I use the 17 standard. Okay, so at 11, the C++ committee decided to come up with a new language standard every 3 years. So there's 11, which is a major break with the past. 14, sort of a refinement on it. 17 introduced, again, a number of big improvements. And 20 was just finalized, but there are a bunch of features in 20 that I haven't seen in any compilers yet. So in this lecture, I will use 17 as the baseline and at most make a remark about 20. Okay, so because your compiler as a default uses, I think, the 98 standard, so you have to tell tell your compiler to use the 17 standard, and in fact, bum, 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 bum. You'll see in my list of aliases that I have aliased my compiler, and I'm using the Intel compiler, but it's the same syntax for every compiler. I've aliased it to ICPC minus standard is 17, and then a compiler specific option that I find useful. Okay, so alias your compiler or spend a lot of time typing this boilerplate. Basically, just use this as the standard. There is absolutely no reason to use one of the older standards. Okay, minor enhancements. In C, there are no booleans. 0 is false and non-zero is true. In C++, there is an actual bool type with values true and false. In C, you can only have comments between the / star thingamies. In C++, and maybe this has been adopted in modern C, there are single line comments. So / means ignore everything to the end of the line. You'll see that a lot in my codes. Type defs are sort of going out the window, so you can say using. I find this useful in some codes. If I can't make up my mind if a code is going to be float or double, then I put a line on top of my code using real is float, and then real is sort of a type def. Okay, couple of minor things. More minor things is if you haven't adopted this in your C programming, please do GCC or whatever standard is C99. Use that as the as your default, because then you can declare your loop variable local to your loop. This is very convenient. No spillage of the variables and possible confusion. If you didn't already know this, so you can start using this in C next time you program. I find this to give much cleaner code. C++ has extended this a little bit, so now in if statements you can have initializers. So just like in the for, you declare your variable local to the for, you can now declare a variable local to the conditional. For reasons that are beyond me, this doesn't work in a while loop. Who knows? Okay. Yeah, so printf is no longer necessary. In C++, the I/O is handled differently. So let's, just to make sure that everyone has a working installation, let's do the following. I'm making a directory. Let's Emacs file basic.cxx or CPP or CC. I use CXX because to me CPP means C preprocessor, but use whatever extension you want. Emacs understands most of them. Yep, Emacs has gone into C++ mode. So include IO stream. I'm sure this is unreadable, so I'll turn off my syntax coloring. Using standard cout, using standard end line, using standard what was it, cin. Int main, same as in C. I could do I could do my int argc int star star argv, return 0, of course. Okay, is everyone following along with me? Come on. Okay, I made no typos. Okay, so enter this program and make sure that your compiler works. Speak up if there are problems, or post something in the Slack if you don't trust your audio connection. Okay, I'm assuming everyone has done this. So yeah, I/O comes with footnotes. So you can do everything with the I/O stream, but in C++20, there is a library that was developed externally called formatlib, fmtlib, which is now part of C++ as of 20. And I will probably put that in a future lecture. So I am not entirely happy with this I/O. It's going to get better in the future, more elegant. All right, so you see that no longer standard lib and standard I/O. There are a bunch of C libraries that are still accessible in C++. So if you need functions in math.h, you can do cmath. And if you really need the C standard lib, you can do C standard lib. But most of these are not necessary anymore. Okay. I am going to talk about functions, and you know how to write functions, but the parameter passing mechanism has greatly changed. The old mechanism still works, but I don't like you using it. Okay, so there are a couple of small changes, default values on function parameters, polymorphism, but the big one is how do you pass parameters by reference? Parameter passing. Okay, so if you write functions, you can, many people advocate a design where you write a function where all the arguments are passed in and the only result comes through the return statement. That style is called functional programming. And it makes for nice and clean code, no hidden side effects. Yes, so in C, all parameters are copied in by value. If you do this stuff with an ampersand and a star, you are not passing by reference. You pass an address by value. Okay, C has no pass by reference. It has only pass of addresses by value. And this is also the basic mechanism in C++, pass by value. Now, you can also write functions where you do not return through the return statement, or you use the return statement, for instance, to pass status information, but you metaphorically return a result by changing the parameters that you, again, pass by reference. And in languages that are cleaner than C, C++, like Fortran, you can have a separate input, output, and throughput parameter. In C, it's a little fuzzier. So you want to pass by reference. Okay, now C did not have an actual pass by reference. C++ does. Okay, what are references? Yeah, C does not have an actual pass by reference. C has references which are new. So I'm going to introduce that next. The ampersand is maybe confusingly still used, but it has a different use. Okay, asterisks are out. If you find yourself writing asterisks, you're not writing C++. First order approximation. Okay, references. Thanks, Jason. So at first I'm going to discuss references independent of function passing, passing arguments to a function. A reference is recognizable by an ampersand in its definition. A reference acts like an alias of the thing it references. Okay, that is abstract blah. Let's look at the code. So I have an int I, and then I make a int reference, which I call ri, meaning reference to I. And now after this second line, ri is a reference to I, but really I and ri both refer to the same memory location, so they're complete aliases of each other. So I set I to 5, and I print I and ri. Oh, by the way, note if you compare to the code that you just entered, C out, and then the double chevrons, the double less than sign. So you give it something that you want to output, and then end of line. But you can string together with the double arrows any sort of material, and in fact, so you output I, then you output a string with a comma, and then you output ri. Okay, so what happens? I have a reference to I set I to 5, I output I and ri, and I get 5, 5. Ri is a reference to I, and so it also gives 5. Note that this ri is not a pointer. I didn't, in C, I would have said int ri is address of I, right? In C++, it's different. After making ri a reference, you use I and ri exactly the same. Okay, I multiply I by 2, I print I and ri again, and I get 10, 10. So ri is still a reference, and now I update ri, I print them again, and they both print 7. Okay, so with a reference, the two variables are really referring to the same thing. Okay, I know of no plausible use of references this way, but just to illustrate to you that a reference is really an alias of the variable. Note that the reference is created ooh, Stephen Gottlieb. If pum 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 pum. That might be legal. Let me try it. or maybe it's not. Nope, that is not legal. You really have to have a reference to a variable. I never thought of that one. Yeah, see in the error message L value. C++ has a very complicated system with L values, which are basically things that can appear on the left side of an assignment. R value, things that can appear on the right side of an assignment, and X values, and it is really sophisticated, and there are bits that I don't understand about yet, or that I only so grasp. Okay, so note that you cannot say something is a reference and then later you designate what it points to. You have to create it at creation. Let me make a note of that as an example of what doesn't work. Okay, now this whole reference bit leads up to how you do functions in C++, how you do parameter passing to functions. So, so look at this. I make a function of an int parameter, and by saying that it's int ampersand, I declare in the function that my int n is a reference to whatever is passed in the main program. So in the main program, I have an int I, and I pass I to f. And in C, this would now be, the value of I would be copied to the function. In C++, if I would have said int n, then indeed the value gets copied. By writing int ampersand n, the parameter becomes a reference to the variable, to the argument in the main program. So the function parameter n becomes a reference to the variable n in the main program. And note that you don't have this complicated int star as in C, where you have to remember that if you want to assign, you have to write star n equals. So this simplifies the syntax considerably. Let's see that in action. I make a function with an int I, which is a reference int variable, and the function sets I to 5. Now in my main program, I declare a variable equal to 0, I pass it to the function and I output it, and lo and behold, whoops, I meant to highlight that, the output becomes 5. Okay, and of course if you leave out the reference, then what? Does anyone want to speak up? Post a line in chat. If I would leave out the ampersand, then it would become 0, still be 0, yes. Because if I leave out the ampersand, then I only copy the value, and so the int I becomes a local variable to the function. Okay? So the C behavior is that function parameters become a local variable to the function. In C++, by putting an ampersand, it is not a local variable, but it's a reference variable. Okay, Yeah, so what if the call to the function contained an expression? Oh, very good. Yeah, in that case, that doesn't work. Um, um, yes. Okay, so I was just saying about L values, R values, expressions to functions. There's some sort of a complicated uh, thingamy, but that's not allowed. I'm sure that the compiler will catch that. It doesn't work. Um, try it out for yourself and see what error message you get. Um, let's see. So this is an example of a function. So this is a Boolean predicate. So sometimes you want to say, okay, try to read a value, and if it was possible, give it to me. If it was not possible, give me a Boolean that says was not possible. So I have a function can read value, which, if possible, returns the value, and if not, returns a Boolean that says not possible. So oops, yeah, int file status is try open the file. If the status is 0, then read it, and regardless, return the file status. And so now you can use this as if not read the value, set it to some default value, otherwise, etc. So I put this example in my book before I discovered that in C++17 there is something called optional, which is really cool. We'll get to that in the afternoon. But for now, as an illustration, that you can return one way and return the other way. So return by changing the reference value, and return by Boolean. So this is just an example of one particular idiom. Okay, just to make sure that you can do this, write a function swap. So declare variables I and j, call swap, so that they get swapped, and I will set a clock for 3 minutes, which allows me to go for a glass of water. So code this, and I'll be right back. And that was my timer. I assume no one had any problems with this. If yes, speak up, or post in Slack. All right. Yeah. So I have occasional optional exercises. Okay, so function parameter passing is the major thing that I wanted to mention about functions. That is a big difference. So don't use ampersand in the function call and the star in the function definition. There is zip reason for ever doing that. Well, unless you get much further, but for basic use, don't write, if you write a star, you're not doing C++. A couple of small things about functions. Functions can have default arguments. So what do we have here? A function distance with two arguments where the second one says equals 0. So that means that if you don't specify the second argument, it takes a default value of 0. And so distance to the origin is a function of 1. Distance between 2 points is a function of 2 arguments. And you can have as many default arguments as you want, but they need to come at the end of the list, at the end of the parameter list. Okay, this is regularly useful. I like writing functions with a Boolean parameter trace, which has a 0, which has a false value by default. And then, so that means that in my code, I don't have to specify yes, no, trace, but only when I really want to trace a function, then I put a true in there. So it's kind of cool. I think I should mention that idiom. Another thing is that functions are now polymorphic, meaning multiple shapes. You can have multiple functions with the same name as long as they can be distinguished by the compiler from their type and number of input arguments. So you cannot have two functions of the same name where one returns an int and one returns a string. That doesn't work. And if you make two functions, yeah, you can have a function, the same name, once with an int, once with a double, but don't expect the casting is then a bit of a pitfall. But basically, if the functions look sufficiently different, the compiler can figure it out. And so this is sometimes useful. Okay, now in C, you may have not been in the habit of writing const. I certainly was never. But in C++, it's a good idea to use const quite a bit more. So the problem of reference variables is that you could inadvertently change something in your calling program. So the problem with pass by value is that if you're passing a big object, then pass by value is a copy, so the whole object gets copied. And you may not want to do that in a computational inner loop if your object is too large. And so you might want to do pass by reference to save on the copying. However, then you might be afraid for inadvertent changes. And I think programming is for half the time protecting yourself from yourself. And so C++ regularly uses the const keyword. And so if you say const in star, Then you pass by reference, so no copying, but by specifying const, you protect yourself against inadvertent altering of the argument in the calling code. Okay, and that takes us through functions by themselves. We're now going to go into object-oriented programming. Everything clear, I hope, so far? This was elementary stuff. Okay, object-oriented programming. What is an object? Okay, objects look quite a bit like structs in C, but a struct is purely about packaging up data. And for objects, you really need to take a different point of view. An object, I'm halfway quoting Alan McKay here, one of the pioneers of object-oriented programming. An object is a thing that you can request to do things. So functionality is the prime driver of how you design an object. An object is defined by what it can do, not by what it stores. The actions that an object can perform are called the methods. And of course, to make possible these actions, you probably need to store data. So that's called the members of an object. So methods, members, functions, data. But primarily, if you design a class is a data type and an instantiation of it is an object. If you design a class, ask yourself, what should the functionality be that these objects support? Objects come in. That's a typo. Objects come in classes where a class is like a data type. You can make objects of a class just like you can make variables of a data type. Okay, so objects are defined by their functionality. So let's take a look at a main program without at first describing how this is done. So I have a class point, and I make a point of 2 coordinates. Sorry, this my formatting wrapped this. This is supposed to come at the end of the previous line. By the red color, you can see that it's a comment. Okay, so I make a point, and then distance to the origin of the point, p dot length. Okay, so you recognize the dot notation from structs in C. So if this had been a C struct, you would have said p dot x, for instance, because presumably this point has an x and a y coordinate. With objects, you also use the dot notation for the functionality, for the members of the object. So p dot length means, here's my object, what is its length? Point, what is the length of the vector to that point? Okay, and 1, 2 is square root of 5 is 2.23 whatever. And then I have another function, p scaled by 2, so here's my point and now it's there. And then again I ask, what is the length? So then the distance to the origin becomes twice as much because I've scaled my point up, and angle, whatever. Not sure what causes that thingy to happen. Okay. Okay, note the dot notation, which in structs is only used for data. In an object is also used for methods. Okay, now how is this realized? Oh, a thought exercise. So I just said that if I create my point from coordinates x, the x and y coordinates, um, in um, in C, you would now actually store the x and the y. But if I need this functionality of length and angle, the obvious solution, thought exercise. So what data does the object need to store to do this? The obvious solution is store the x and the y. Is there more than one possibility? Feel free to unmute yourself or post a line in Slack. So look at it functionally. I need the length of a point and I need the angle. Yep, thank you. Radius and angle. So even though it looks optional argument with the dimension, yeah. This is a toy example. Let's ignore that for now. You're absolutely right. But let's say I'm writing a drawing program here. As long as screens are two-dimensional, this works. Okay. Yeah, radius and angle. Right. So even though I create a point by specifying the x and y coordinate, that does not imply that I actually store these. I could convert them to radius and angle, and then I could equally well have the length and angle functionality. Sorry, radius and yeah, radius is yeah, r and theta. Very good. Okay, so how do I create a point? So point p of 1 comma 2. Here's the syntax. So I declare class point, and in this case, private means here comes the hidden part of the object, and indeed I am storing a double x and a y. So these are the data members. By saying private, I enforce that any code outside the point class cannot get at the x and the y. So I've basically made this implementation independent. Now, public is a declaration of the methods of the class, the functionality that is visible outside the class. Okay, so my point is created from two floats or doubles, and so I write a function point of a double, the in x, in y, and what does that function do? It copies the input arguments to the hidden data members. Okay, has anyone seen something fishy? If you write Python, you also say class point, but in Python, where is the copying done? Okay, so in some respects, I'll leave that question open. If someone speaks Python, feel free to post it in the chat. C++ looks a little like Python in places and looks different from Python in other places. And this is one of the other places. You have your class point, and then you have a function point which has the same name as the class. So if there is a function with the same name as the class, that's called a constructor. And that is the function that is being called when you write this line point v of 1,2. Okay, and you see that this is also a function without a return argument, because what it returns is the thing itself. No Python programmers? Okay. Yeah, it doesn't require self, correct. Yeah, that's one of the differences with Python. Init, yeah, strictly speaking, underscore, underscore, init, underscore, underscore, but yep, very good. That's what I was talking about. So Python works differently. It's a function with a pre-specified name. In C++, it's a function with the same name as the class. Okay, so you have a class with a name, and then the function with the same name is called the constructor. And that's where you, for instance, can do the data initialization. Okay, so here the constructor does an explicit copy. While you're getting used to this, I'll immediately burden you with the next mechanism. For a variety of reasons, it is better to use the following syntax for initializing the data members. So you have your function, you have your argument list, and then you have the function body. But in between that goes a brand new notation. So if in between the parameter list and the function body, there comes this thing with a colon, that's called an initializer list. And that is the preferred way of copying arguments to data members. Really, that is the preferred way. In case of integers, it makes no difference. But if your class contains other objects of any substance, then this is better. Okay. Yeah, just like in C structs, you can have default values. Just to illustrate the radius angle point. So suppose my class point does not store x and y, but it stores r and theta. Then I have a constructor with the same syntax, right? So to the user of this class, there is no difference, but internally I store something else. Okay, so by keeping the data members completely private, it means that the code that uses this thingy, the code that uses this class is completely independent of the implementation. I can change my implementation without the calling code having to change. Very important, clean coding. Okay. Don't you need Aton 2? You'll have to explain, Stephen. I know that I'm probably in an absolute sign away. Does Arctan?
Well, if x and y are both negative, you'd get the same ratio as if x and y are both positive, and those are 180 degrees apart.
Oh, very good. Yeah. I didn't know about that bit of the math library. I will make a note of that. Thank you very much. I'm not pretending to give bulletproof code here. It's to illustrate the principle, but yes, I might as well be right. All right, so yeah, so I showed you this code that uses the point class, but the only thing I've shown you so far is how to make the constructor. Now we're going to be looking at how do you implement these methods that give you the actual functionality. Okay, So inside your point class, and I'm going back to the simple-minded design with storing x and y. Oh, right, and I'm using the most confusing initializer list syntax. X means data member X gets initialized from argument X. Anyway, but so let's say we've disposed of the constructor. Now I need to write the functions length and angle. So what is the length of a point, meaning distance to the origin? Well, it's the square root of the sums of the x and the y squared. But what's happening here? So this formula is obviously correct, unless I miss something again. But where do the x and the y come from? They are neither parameters to that function, nor are they local variables. Okay, so where do they come from? Okay, this is the magic of the object-oriented programming. Any function inside the class can use variables defined inside the class. So any method can use the members as global variables. Okay, so when I say x and y, I mean the x and the y that are stored in this object. So with the constructor, you pass x and y values from the outside and store them in your local variable. And now you have an object with an x and a y stored, and you can ask that object, what is your length? And it says, well, that is the square root of my x squared and my y squared. Yeah, okay, and so now this code works. Okay, this is something that you need to internalize. There's something weird about this, but by having this line, you create a point that internally has 1 and 2 as x and y, and then you can ask that point, what is your length, distance to the origin? It says that is the square root of my x squared plus my y squared. Okay, now, so what I did here is the functional programming approach. I took the internal x and the y, and I returned a double based on this. But you can also do the following. Okay, let's look at the main program first. So I make a point 1, 2. It has length square root of 5, which is 2.23. And now I say, okay, point, scale yourself by 2. So I'm not catching any return result. I'm saying, okay, point, I want you to scale yourself. And now if you do p1.length, you get the double of 2.236, which is 4.472. Okay, so some methods return something based on the built-in, on the stored data. Some methods change the, to use the technical term, the state of the object. Okay, so an object is not a frozen thingamy, it's something that you can alter. So with the constructor, etc., being what we had in the previous slides, now the method scale by is a void function because there's no result, but it takes a double and then, oh, sorry, my code is not entirely in sync with itself. So x and y have suddenly turned into vx and vy. I will make a note. Let's see if I can open the toolbox and how do you write on a screen? Okay, X. Okay, but I hope you see my point. You now have a method that doesn't return anything, but it changes the internal state of the object. You can even, so suppose you want to preserve the original object. So you have a point P, it gets created somehow. You have a point, it gets created somehow, and you print its length. And now you want a new point that has the double length. So let's contemplate making a method called scale, which takes a point and gives you a new point. And then P2 has the double length. Okay, so how would you do this? The implementation of that, okay, yeah. I've been without power for 4 days, so I'm actually 4 days behind on preparing for this course. This slide needs a little extra, so ignore the little bit that I've highlighted. We'll get to that in a minute. So I have a function scale, and it returns a point. And how does it do that? It makes a new point by creating point. Oh boy, oh boy, oh boy. This is, in fact, yeah. So I'm overfeeding you here with confusing syntax. This slide definitely needs sorry, class point. There was the private stuff, public stuff, and what was I doing? This is the function scale. Okay, no, point scale double A private double XY point scale. Okay, so you could do, so I want to return a new point, so I could do point scaled point is A star X, A star Y, and then return scaled point. Okay, this is perfectly perfectly acceptable. Let's call that scale 1. Scale 2, what did I have? Oh, right, sorry, this is in fact what I, there's no scale 3. So what did I do? Oh no, there was a scale 3. Point scale point. Yeah, you can even do this. So instead of the syntax point, scaled point like this. You can do this, so you make an anonymous point and you assign that to a temporary variable, and then you return the temporary variable. But you might as well use the anonymous point immediately. And return that thing. I will update the slides and you'll get a note when it's there. Okay, so there are different ways, and for now do whatever feels most intuitive to you. So basically there are three different ways of creating a new point and returning it. So it looks a little confusing. There is a point here, there is a point there, and there is a point there. So this one is create a new point. And then this one says the return type of scale 3 is a point object. Yeah. Point, come on. My fingers are cold. Double X, double Y. X becomes X, Y becomes Y, and for the rest we don't have to do anything. Yeah, okay, I can code this out, but okay. Yeah. Why don't you basically take most of the code of the slides and put that together in a file. Put that together in a file so that you can do, for instance, you yourself write a printout method. There's going to be a couple more exercises that use this material, so put the stuff together and get it working. Okay, so exercise 4, you can copy it from the screen or you can copy paste from the slides. Michael, very good point. Yes, okay, so Michael raises a point in the chat that here you're creating a local point and then the return probably copies it. So you had point A is 1, 2, and then point B is A scaled by 3. So there is storage for point B and there is storage for the internal point. Yeah, so it creates multiple thingamies and copies them into each other. Okay, so this is one of the reasons that this syntax is preferable, because now the compiler is clever enough that it can eliminate the copies, and so it creates something here and it immediately writes it into B. Very good point, but this is a technicality. So for people who have by now no clue what I'm talking about, just ignore me and write whatever feels most intuitive to you. I really, at the ground level, want you to get confident with just the object-oriented syntax. But it's a very good point, and modern versions of C++ really work on omitting copies as much as possible. Thanks for bringing it up. And if you didn't get that, ignore me and ignore Michael. Okay, do the exercise. So write your own point class, which has a printout method. Write a main program that tests it. I'm setting a timer for 10 minutes. And I am taking a short break myself. I am muting myself. Everyone doing okay?
Yes.
Great. Oh, one point that I didn't emphasize. I think in C you don't need the semicolon after a struct and not after function definitions and all that. C++ insists that after every method you have the semicolon, and at the end of the class definition there should be a semicolon. So the compiler is kind of picky about that. Anyone get any completely incomprehensible error messages? So let's start filling in the blanks. I have the code here. Code here on the screen. So the method print out. Does it take any arguments?
No.
No is the correct answer because it's just print. I guess in a more sophisticated world you want to pass in what standard file to print to, but for the moment print out. Okay, so that means that the function print out has no arguments, right? So paren. Return type.
Should it be void?
Should be void indeed. Yeah. Yeah, if you think so if you try to compile this, I'm being nice and cryptic here. Does everyone understand what I'm typing? Oh boy, there's a lot of. So what I did was take the last command that started with IC, which was compiling the ref file, and then substitute ref for point globally. Unix is such a power user system. Anyway, right. Oh, I forgot. Not called scaled, it's called scale. Scaled should be. I'm trying to get rid of the non-obvious compiler error messages, and that 3 was wrong too. And what is left is that printout is missing an explicit type. So that is an error that I still occasionally make. I forget to put a return type. So yeah, the return type is indeed void. And what do we do here? Cout. Oh, something like this. Agree? So parens, comma, and then the 2 coordinates. Okay. I created it from, what did I do? 1, 2 times 3. Yep. Okay. No questions about this? Then here's the big one. Extend the point class of the previous exercise with a method distance that computes the distance between this point and another. So so our points are double or float, whatever, distance to another point, and return what? Give it some thought. What is the parameter? So you should be able to do, you now have points A and B, and you want to print out, here the slide already gives you what I want the functionality to look like. Okay, so if P and Q were structs in C, you would write distance P comma Q. Okay, but here you say, okay, point P, what is your distance to Q? It's a little matter of emphasis. To some extent, you could consider object-oriented programming to be syntactic sugar around normal procedural programming. Okay, I'll set the clock again for 5 minutes. Think about it, and if you run into questions, if you're totally puzzled, post a question in Slack or speak up, whatever. 5 minutes. Do this exercise. So what should that function look like? Try to write it. So first of all, the question, what is the parameter list of that distance function? It's a distance. Yeah.
It should just be the point Q or the extra point that.
Yeah. Let's call it other. Right. Did anyone write this? So that's kind of counterintuitive at first. You may be tempted to write it like this because the distance is between 2 points, but one point is yourself, and you don't have to specify yourself explicitly. So indeed, it's a function, and boy one, forgive me pronunciation of your name, you are absolutely right. So dx is something, dy is something, and then return the square root of dx times dx plus dy times dy. And the question is, what is dx and dy? Delta x, I mean, right? Right, so what is the x distance between this point and the other one? So that should be x minus some other x. Okay, how do you get the other x? Now, there are two solutions that you could have taken here. Does anyone want to volunteer one solution? How do you so when I write x here, I'm talking about my own x. How do I get the other x?
You can use the length and the angle from the other point.
No, this implementation is not using a length and an angle. It's completely Cartesian, x, y. So I need the x of the other point. That is correct. Can't you reference other as x? Yes, but precisely how do I do that? Nothing deep here. Okay, yes, that is indeed other dot x. Same syntax as structures. Classes and structures are in C++ extremely alike. So the C struct notation with a dot you use here, and the delta y is y minus the other y. And then you return this haha, yes, Ju1, that is a very good question. Oh, what am I doing here? Square root is undefined. Hash includes CMath. And Q is undefined. What did I do wrong here? Oh, right. That's B. Okay, let's assume that that number is correct. Okay, so some subtleties. Yes, so x and y are private. So this is why I wanted you to do it yourself, so that you may run into these questions. So x and y are private, and so why are we allowed to to write this? Well, it's not private to yourself, but it's private to anyone of that class. It's a design decision that you may quarrel with. But basically, yes, even if it's private, another object of the same class, private, but object of the same class, come on, class can access. Now, you could also do the following. Did anyone do this? Did anyone do this? Write a function get my y, which just returns the y value, and then do y minus the function get my y from the other. So that is a solution too, but I don't like this. And potentially dangerous. Well, no. Let's just keep it like this. Okay, so there is a temptation to write this sort of functions. Okay, y, so let's call it my y. There is a temptation to write that sort of functions and then use that in your main program. But remember that what counts for objects is the functionality. And getting the x or the y coordinate is not a functionality. That is tinkering with data. And so you should really think, if I have a point class, what is the functionality I want? Okay, I want distance to another point, I want angles and that sort of thing, but I do not intrinsically want the x or the y coordinate. You use that to do something else, and in that case you should write the else directly. And there are more problems with this. We'll get to that. Okay. Yeah, okay, so you can do this one when you get home. Now, if you have 2 points, point P and Q, write a function h that gives you the point halfway P and Q. If you did the previous exercise, then this should not be terribly hard to do. Okay, here's a subtlety. So suppose you want to write point P1 is something, and then I make a variable P2, and I later in the program say P2 becomes P1 scaled by something. Now this looks perfectly plausible, but depending on your compiler, you get various error messages. Let's see, point C is